Okay, so welcome everyone to the third edition of Stay Home, which is a new initiative from Speck&Tech.
Stands for
And for tonight,
Speck&Tech at your home.
exactly. For tonight, it's particularly important to get to this link. If you can open just a tab on your browser, on your phone, wherever you like. It's the usual one, but tonight is particularly important, and you will see later why. Slide.do/stay home. This is the third edition again, and as we said before, this time it is sponsored by AWS. We have Alex, who's our speaker.
Welcome, Alex.
They were particularly kind to support us. Actually, Alex should have been one of the speakers of the event that never happened last March, that never took place because of coronavirus, and that's why we moved everything online. For the people that do not know us, we are a community based in Trento. We started in 2016. This was one of our normal events, let's say before COVID. Around 100, 150 people gathered in a room with no social distancing, as you can see, talking about tech stuff, and at the end of the event, time for Speck and beers for everyone. We've had some very great speakers. We've got Cloudflare CTO, which is actually the first speaker of this online edition. If you're interested, just get to our YouTube channel and you can see the interview with him. Then we moved to a new venue. The format remained the same. When we met offline, we actually had two talks. Now we only have one. And we've organized a couple of interesting events, including our retreat, where we gathered all the community in the mountains, talking about tech stuff, enjoying swimming in the pool, enjoying sauna, hikes, and stuff in the mountains, all together with the rest of the community. So we are there. We've organized over 40 events in these years, and we are back online for now. We hope to be also back physically in the future, but God knows why.
We still exist in a physical form. Me and Francesco, we are still people. We're not just on your browser, but we will come back like in the same room as well. Promise.
Yeah. And so this is the third event. I'll hand it over to Giulio.
Yeah, all right, sorry. Giulio, which is very tired tonight and is sleeping while Francesco is calling him. All right, so we have Alex Casalboni from AWS. If you don't know AWS, I have no idea why you're here tonight, but jokes aside, is the Amazon Web Services, which is basically whatever you need for your backend and web services. And no, we won't have a disco ball tonight. I'm sorry, Riccardo. And... All right, so if you want to relive our past events, both on physical, both in a physical way or digital way, like the last three events, you can go to www.speckand.tech. We have all the recordings, slides, and so on. If NDA is permitted. That was before moving everything online. Now basically everything is recorded because of the online shape. Don't forget to subscribe to our YouTube channel, the place where we are now. Subscribe and activate the notification. At least that's what they say when you are on YouTube. I have no idea what the notification does. I never pressed it because I'm afraid of notifications. And follow us. We mostly post on our Telegram channel. We don't spam, promise. We just write when the next event is, and if there are like super interesting other events. Then we have Instagram, Twitter, LinkedIn, Facebook, and all the other social if you are a boomer. And lastly, can I support? Yes, you can, like AWS did. Thank you very much. You are awesome for helping us doing better events and better merchandising and keep doing super good stuff. Also, a huge thanks to Speck&Tech, which is Francesco's company, and Belka, which is the place where I work at. So this is like a moment where I pat myself on the shoulder. Good job, Giulio, and people that work with me. Thank you very much.
And if you're interested, we are hiring as always. So just get in touch with us.
All right.
Despite coronavirus.
Yeah, Spaziodati is awesome. You should definitely check it out if you are in Trento area. I don't know if you hire remotely, but this is a hard question, which I leave to your HR people. And yeah, if you still want to send us money to the next events, basically we will use them to pay for beer, spec, and rent for the location as soon as we can go back to our physical form, which now sounds like we are a cloud entity based on your computer, which is kind of true.
And of course, you can contribute to the t-shirts.
Oh yeah. And also, you can buy the last remaining T-shirts without the hair is not included. So if you don't have much hair, I'm sorry, we won't help you. We would really like to though.
And here is where we come to the most important topic of tonight before Alex talk, because we're talking about T-shirts and we've got some big news. So first of all, go to slide.do/stayhome. If you're not there, you should, because you will be able to contribute to the whole community. And here we come to the big news. We've got 2 designs for this year. Coronavirus t-shirt, coronavirus edition, the Stay Home 2020 edition. We thought that it was important to still have a trace of Speck&Tech in 2020 since we didn't stop. And as you can see, everybody's at home, but people at home are still together in front of Speck and beers.
Yes, so and on the option number 1, we have... No, torna quella prima, Franz, la stavo un po' caricando. We have green on yellow, which those very long and sexy houses that are speaking and eating Speck together. And on the second proposal, we have space pink on black. If you want to be a little bit more hipster, I'm not totally suggesting my favorite one right now. Please vote this one. Right, Francesco? And
now time to vote. We're going to give you 1 minute. So tell us which one you prefer. I'm actually very excited by myself, and that is the reason why we are asking you, because we voted internally and still we couldn't figure out which was the best one. So we've done the last 2 ones were actually dark, so I would go for a light one, but the dark one is still very cool. So it's a very, very good question.
Yeah, by the way, I had no idea that Slido could do that. Like, it's a very good product.
Yeah, I see around 20 people voting at the moment, so it is your moment right now. If you haven't done it, you can vote for Speck&Tech new t-shirt. And you can even vote both if you're a very undecided person. Well, there's more than 20 people that voted up to now. 25. We're giving you 1 more minute. Over 30 at the moment. Right. Okay, let's say that when the clock hits 20:57, we will start again. As you can imagine, due to coronavirus, we won't be able to distribute them at our physical events in the upcoming months, but nobody knows what's going to happen in autumn. So before we actually print them and prepare them and get them ready to distribute them, it will probably be around August or September. So it's very likely that when we're back with, I don't know, hopefully not a second wave or with a gathering that might happen in September, we might be able to distribute them hand to hand by hand, and maybe you can pass by our offices and get your t-shirt. As always, it will be both male and female for this t-shirt. The price will always be the same, 15 euros. We don't charge that much, but still it helps us save some money for the association. And as you can see, there are 2 different colors, and we will tell you later on in the night which one was the most voted. So at the moment I see over 30 participants, and it's 20:57. Exactly.
So
and
it's
I would call it the end.
9, 8.
I'm closing the survey
7
now.
And it's closed. It was at 7, obviously.
It was a bit okay, a bit faster. Okay, we will tell you later, and that's more or less it. we hand it over to Alex for the night. Again, thanks again for being here. Feel free to tell us a couple of words about AWS before starting. For everyone, the link is always the same, slide.do/stayhome, and you can ask questions to the speaker directly, who will answer them at the end of this talk. Thanks again. I'll leave my presentation to Alex.
Yeah, also thanks, Alex, for the patience, for our voting, a very important question.
Of course, no worries, guys. Okay, so while the screen appears, I just wanted to thank you guys. I also co-organize some meetups in Milan, and I know how hard it is to keep a community alive during 2020. So thanks for your work and for inviting me, or for letting me help you. I'm definitely missing the Speck, the beer, and the mountain. So maybe next year or later this year, we'll get a chance to meet in person, and maybe we cover some other topic as well. And by the way, if we have no idea what AWS is, you are still you're super welcome. You're still in the right place. No worries about that. I'm not keeping an eye on the live questions, but if there is anything critically important, just stop me, guys. Okay, I'm super happy to take questions when the question arises. Waiting 45 minutes sometime doesn't help. So what are we talking about? There is a lot to talk about. Actually, I'll try to compress it to about 45 minutes. My goal was to talk about serverless architectures. If you have never heard about serverless, it's okay. But before doing that, I wanted to give you a few information about me, a few shameless plugs about things that I do, and also a little bit of overview about what AWS is. You might think AWS is just serverless.
Alex, just before starting, can you hide the bar of the Google?
Yes, thank you for reminding me.
Go on.
Thank you, guys. Better, yes. Okay, so let me go straight to it. So I'm a web developer. I've been working in startups for about 5 years between Italy, Switzerland, and California. Now I work for AWS, but before that, I was an AWS customer for almost 5.5 years. So if you have any questions, just throw them at me, no problem at all. You can find me on most social media and publishing platforms, or I also do some Twitch, live streamings and so on. Feel free to connect. What I want to talk about tonight, a little bit, literally 5 minutes, about what AWS is, and it's pretty hard to compress it in 5 minutes. We could do 45 minutes just about that. Then I want to talk about serverless fundamentals, just to make sure everyone is on the same page before we go into the architectural patterns. Why patterns? Because when you work with the cloud, you start building up your architecture by using services, by gluing them together. So being aware of what's possible, what services are there, is, in my opinion, one of the main problems in 2020. So I categorized a few different patterns in categories. The first one is for web development and RESTful APIs in general. Second one is for data processing, especially in the real-time world. Third is for data analysis, so not necessarily in real time, but more into the big data kind of way. And then I also want to cover the idea of embedding intelligence or artificial intelligence services by using this idea of serverless architectures too. So maybe you don't care about all of these. My goal is to let you know, let you become aware of what's possible and what you can do with the cloud in 2020, especially with serverless computing. But one step at a time. So what is AWS in the first place? If you have never heard of it, or maybe you have heard of it, but you haven't really used it, you think it might be useful, but you haven't tried it. And even before that, I have a couple of shameless plugs of things that I do and things that might be interesting to you. This is just a reminder, actually, that there is an AWS region, physical infrastructure created by AWS in Italy. I imagine that many of you, if not most of you, are from Italy or work for Italian companies with Italian customers. So I thought this might be a good reminder for you, just to remember, you want to keep data in country, you want to lower latency, because having physical infrastructure in country is important. Just a reminder for you. The second shameless plug is a personal project that I've started a few months ago already. Wow, yeah, like 3 months ago. A lot of customers in Italy asked me to publish more material in Italian. This is not what I'm doing. Anyway, I've started publishing a podcast in Italian. So every Monday I publish a new episode. We talk about a lot of different topics with guests, with customers, with colleagues from AWS Italy. So feel free to have a look if you like podcasts in general, or if you want to learn more after this presentation. Enough plugs for tonight. Let me tell you what is AWS in 5 minutes. I'll try to compress it. I would imagine that many of you are aware of what it looked at, let's say what IT looked like before the cloud came. The cloud was, as a word, as a concept, was invented in 2006. So that was 14 years ago. And before that, IT was basically buying physical hardware, connecting the wires, installing software on it, and hoping it works. And there were teams and companies and whole businesses just focused on that. In a way, a lot of people will come to you and tell you, well, what if I told you that the cloud is just someone else's computer? Because at the end of the day, if you want to spin up some code, some software, some services, you need to buy hardware, mount it somewhere, buy power, electricity, cooling, connect the wires, install something on it, and then run whatever software you want to run. So at the bare infrastructural level, yes, the cloud is somebody else's computer that AWS, in this case, is managing, securing, installing, provisioning, patching, everything you need to do with physical infrastructure. But at the same time, this was more of a okay joke, let's say 10 years ago. I'm not really convinced about this anymore. I hope by the end of this presentation, or by the end of this 5-minute intro, you will agree with me. So from a developer's point of view, the way I see it is that the cloud allows me to build things faster. Because in the old world, where I needed to buy physical hardware, connect it, install it, do all those things took months. In the best case, weeks. If I was very, very good at it, at capacity planning, and I really knew what I needed, it took days. What the cloud allows you to do is that all those things take minutes, seconds, sometimes even less than seconds. As we'll see with serverless computing, you can create services and cloud infrastructure, cloud resources in a matter of milliseconds. So, that's quite a game changer. So you have resources that are quick to provision. You have a platform where you can find all these potentially useful resources for you. And that means that as a developer, and ultimately as a company, you can just be faster in whatever problem you are trying to solve. And this might be, maybe you give it for granted, but believe it or not, the largest majority of IT still works on the idea of buying physical hardware, physical infrastructure, owning their own data centers. So that's not still, I would say that cloud is the new normal, but it's still not the largest majority. There are still a lot of companies, maybe your own company, where the cloud is still the future, not the present or even the past. So what does this platform look like? What do you have in it? I do not pretend you can read this slide. There is a lot of it. And the goal is not for you to read every single service or every single capability. What I would like you to focus on is the breadth, is the spectrum of services that exist out there. And let me tell you that, okay, all these things could be categorized into 3 categories. What you would expect from the cloud 10 years ago, what the cloud was, let's say 10 years ago, it was born 14 years ago. You would expect to have compute capacity. You wanted to have maybe some managed databases that, that some service that doesn't force you to spin up a cloud instance, a virtual machine, a server, and install additional software on it. You wanted a MySQL database, cool. I just, you click a button and you have a MySQL database. Maybe you wanted some physical, some virtualized infrastructure capability, like virtual private clouds or a CDN distributed around the world. Maybe you wanted to add the possibility to migrate data, to migrate existing workloads. You wanted to have networking services. You wanted to have storage, of course. If you have data, you have compute, you need storage. Okay, these things are, let's say the few building blocks that the cloud built more than 10 years ago. If you still think that the cloud is just compute, storage, networking, and physical infrastructure, you are in 2010 as far as what the cloud is. Let me tell you what the cloud is today. What the cloud is today is a lot more. AWS, and to be honest, most cloud players have been building on top of those basic primitives of the cloud to give you things like data analytics service and interesting orchestration and integration capabilities. Or even, let me give you an example. End user computing wasn't even a thing 10 years ago. Things like remote desktops, or imagine during the lockdown how many companies had people staying at home and they still needed to connect to VPNs, or they still needed to have proprietary software, or they still needed to have specific software or access to resources that they couldn't access from their laptop. A lot of companies have been using services like Amazon Workspaces to have their virtual desktop in the cloud, just accessible from a desktop application. And that has a lot of advantages for bandwidth, for licenses, for even just the speed of the network. If you need to download something, it's the network of the cloud provider, not your own home Wi-Fi. Or things like Internet of Things, developer experience, tools and frameworks and libraries that help you build things faster in the web world, in the IoT world, in the machine learning world. Things like mobile development, media services to transcode videos and serve multimedia assets to a global audience, or security and compliance services that help you build applications that are secure by default, and things like that. This is what the cloud is today, but there is still a lot more that is helping companies build the applications of the future. Let me quote just a few. If you're building applications in the virtual reality world, if you need something like a managed blockchain or an immutable ledger for your specific blockchain-based applications, or if you are a game company and you need a cross-platform 3D engine, or a multiplayer game engine that scales thanks to the cloud, there is a lot in that space too. If you need machine learning, we'll talk about it later in the presentation. There are more machine learning services in 2020 that there ever were in the history of IT. If you're working with robotics, if you're working with satellites, there is a service, an AWS service called AWS Ground Station, that helps you get data from satellites orbiting Earth. So if that's your business, you don't have to build a lot of ground stations around the world. That is actually the largest investment if you're working with satellites. So you can just focus on building and launching the satellite, and then we'll collect the data, and you can access that data on Amazon S.T.A.Y. or the typical cloud storage services. So these are the services that will enable the future. So if you come back to me and say, I still think the cloud is just someone else's computer where I need some compute capacity, some databases, and some storage to run my code, I don't know. I hope I convinced you it's not like that anymore. But let's focus for a second on the computing side of things, because in the end, it's cloud computing. The computing services are probably the core, the foundation. Also, let me introduce you to the responsibility model, the shared responsibility model. There are two very important concepts when you talk about cloud. Maybe you've heard of it already. It's this idea that security is a shared responsibility. So the cloud provider makes sure that the cloud is secure in the sense that we take care of the security of the cloud. So all the physical protection to make sure that everything is encrypted on the hardware, to make sure that the software and the operating systems are patched if you're using higher level managed services, things like that. On the other hand, the users, the customers, are responsible for the security in the cloud, everything that runs on top. So sometimes this is perceived in a strange way, like, yeah, so it's half and a half. Well, it kind of depends on which services you're using and where you decide to build your applications and your business. So let me give you an overview of what this space looks like. If you talk about, this is the compute line, and we have the consumer space, things that the customer has to do, the consumer has to do, and the provider space, so things that the cloud provider is taking care of. So the more you go right, the more you go up, the more the provider takes care of things. So there are different abstraction layers when it comes to computing. You have physical servers, you have virtual machines, you have containers, and then you also have functions, function as a service. That's what we are talking about tonight as well. So historically, you have probably heard of Amazon EC2, Elastic Compute Cloud, and services like Lightsail that give you the virtual machine, the cloud instance abstraction layer. As you can see here, it's almost 50-50. The cloud takes care of a few things, and the customer takes care of whatever code is running, whatever application is running on those instances. There is also an even lower level alternative to that. If you need bare metal instances where you also install the hypervisor, not just the operating system, but also the hypervisor, you also have bare metal instances. If you go one layer up, you have the containers world, where a lot of the details about virtual machines and the operating system layer is taken care of, and all you care about is your containers, whether it's a Docker container, whether it's a Kubernetes pod, and things like that. You have services that help you there, things like Amazon ECS, things like Amazon EKS for managed Kubernetes, and on the top right up there, in the highest abstraction layer so far, you have the idea of functions. So things that the largest majority of issues and challenges are taken care of by the provider. The virtual machines, the physical infrastructure, the runtime, and the containers where the functions are running, everything but your business logic is taken care of. So you can really just focus on the business logic. Which brings me to the question for tonight. What does serverless even mean? Why is serverless computing? Where are the servers? Well, as you can see from here, the servers are still there. It's just that they are hidden behind a few layers of abstraction. You don't talk about containers anymore. You don't talk about instances. You don't talk about hypervisors, virtualization, and physical infrastructure anymore. We are up there. And as developer, what we want to do, what we really, really care about, is implementing and adding value thanks to some business logic that solves a problem. So I'm a web developer myself. Maybe many of you are web developers. Your goal is not to orchestrate containers. Your work is not to maintain an operating system applying security patches every 2 weeks to your virtual machines. That's not what makes you productive. What you want to do is solving problems with your software, with your code. So what we want to do is just focus 100%, or maybe not 100, let's say 90% of our time, of our efforts, or our focus on the business logic. So as you've probably imagined at this point. It's not like all black and white or all, you know, true or false. It's not like you are either fully serverless or not serverless at all. There is actually a spectrum. There is what we call runs on EC2. So you just pick almost the lowest layer and you implement stuff on top of it. So most things are up to you. There is stuff in between where, you know, you find things like managed services, like managed databases and serverless containers kind of stuff, or orchestration services like SageMaker for data scientists. But then you have the really serverless stuff. And what is really the difference? What does this categorization tell you? Well, in these services here, what disappears is the concept of server, the concept of cluster, the idea that you need to quantify how many servers do you need. You don't need to care. The service will take care of that scalability for you. And it's not just compute. AWS Lambda is the computing service that made this serverless revolution possible about 5 years ago, 5-6 years ago. So now you can say that you could potentially have 5 years experience in serverless or with AWS Lambda. But it's not just Lambda. It's a lot of different serverless services that help you build functionalities without reinventing the wheel. So things like authentication and real-time streaming and distributed tracing and object storage and RESTful APIs, all these things you can do without having to worry about a server or a cluster of machines or a cluster of containers and pods and Kubernetes, you know, whatever you're doing right now. So in different words, serverless means that you're not provisioning, patching, managing in general any server or cluster or container. It means that the scalability, the scaling is automatic. And it's automatic not in a matter of hours, weeks, or even minutes. It's automatic in a matter of hundreds of milliseconds. So in a matter of 200, 300, 400 milliseconds, you can have new functions spinning up and serving requests for you. No need to wait, no need to configure a change or deploy a new version. Everything happens automatically. The best thing, in my opinion, is that if nothing is running right now, you pay zero. So we used to say you never pay for idle compute, because what happens with EC2 and ECS and other container or instance-based workloads is that if you spin up an instance and then you don't use it for a week, you're still paying for it. What happens with serverless is that if you don't use it, if there are no requests for an hour or for a day or for a week, you're not paying for that, because you only pay for when something happens. And that's why we also like to say that it's all event driven. Everything with AWS Lambda is an event. The fourth advantage here that sometimes is not, is forgotten by developers is that because of that, abstraction layers are hidden and managed by AWS, by the cloud provider. You get the best practices, you get the benefits of security and scalability and operational excellence that the vendor, the cloud provider, has been building for you in the last 14, 15 years. So you don't have to learn about availability zones and resiliency and networking across different data centers. All that complexity is hidden but taken care of. So even when you look at the different costs of computing platforms, of course, if a computing EC2 instance, if you run it 24/7 for a month, will definitely be cheaper than a Lambda function that runs 24/7 for a month. But first of all, you only pay for value. So it's very unlikely that you are running 24/7 for a month. You only run when something needs to be done, like an HTTP request or a new object on S3 to be processed. But also inside Lambda, you have the best practices like multi-availability zone deployments for resiliency and stuff like that. But who is adopting it? Well, I can't. I'm not going to read all these names. You can probably recognize a few logos and names and customers, but I can tell you that 9 of the 10 largest AWS accounts are using AWS Lambda and serverless computing for different use cases, for a different scale. But it's not just a new trend that is emerging that only startups are using. It's something that has been there for 5-6 years, and it's being adopted a lot because companies realize that you can build faster by owning less infrastructure and by achieving even better cost savings, especially if you are in a world where your traffic is infrequent or your traffic is unpredictable and it's pretty hard to do capacity planning. In those kind of use cases, serverless can help you a lot. I'll give you an example. There is a company here, iRobot. iRobot is a company based in Boston, in the United States, and they build their Roomba, those bots that clean your house. Okay, every time those bots talk to the cloud to save some data, to call an HTTP API, whatever they do, they are talking to AWS Lambda, they're talking to a serverless backend. And why is it important for them, for this backend to be serverless? Because, as you maybe have done, like me, when you buy a Roomba and you gift it to your grandmother or to your someone in your family, like at Christmas time, there will be hundreds of thousands of new Roombas spinning up on Christmas Day, believe it or not. So what happens is that they see a peak during specific day, like on Christmas, after Prime Day, after Black Friday, all these kind of huge peaks. They see a peak of 100x the traffic they usually have. Not 100%, not twice as much, 100 times as many requests per second for a few hours. So if they had to over provision to be able to manage that peak, they will never be able to afford all those servers and all those machines. Anyway, serverless gives them the ability and the flexibility to manage a fleet of 2, 3, maybe 3.5 million robots around the world talking to the cloud. So pretty cool use cases out there. So what happens when you deploy a serverless function? So we have mentioned that you only pay for when something is going on. Everything is event-based. I haven't mentioned that you can use almost any programming language that you like. It could be Python, Node.js, Java, Ruby, Go, .NET, whatever. What happens in practice is that when a Lambda function execution is triggered, we need to go and download your code, start a new runtime or a new container. It's actually a micro virtual machine powered by Firecracker, an open source project released by AWS. And then we can finally bootstrap the runtime, depending on the language that you have chosen. And then we can finally run your code. Okay, your code is just a little piece of, 20 lines of Python, 20 lines of Ruby, just a little handler with some business logic. And, this initialization part in the container or in the instances world might be a couple of minutes or maybe 40, 50 seconds. Okay, in serverless computing, this is 200 milliseconds. Okay, so this happens very quickly, and this can spin up in parallel as quickly as possible so that you can serve a lot of concurrent requests. Also, it's important that you cannot really choose how many cores, how much memory, how much networking throughput you have. All you can focus on is the power. There is this idea of memory, but in practice, when you give more memory to a Lambda function, you are also allocating more CPU and more networking, more throughput, more everything. That's why I like to call it power. You can go from 128 megabytes up to 3 gigabytes of memory. But it's not really about the memory. It's about how fast, how performant, how fast you want this function to be, basically. Especially if your workload is CPU bound, if you give it more memory, it'll be a lot faster. And if something is a lot faster, in a system that you pay by 100 millisecond intervals like Lambda. If you give it 10 times more memory and it runs 10 times faster, you are paying the same, right? Also, I didn't mention this so far actually, but if your code runs for 300 milliseconds, you pay for 300 milliseconds. There is no hourly, monthly, or there is no cost by the minute or even by the second. It's by 100 millisecond intervals. So this was the fundamentals. This was to make sure that everyone's on the same page. If you have never ever heard about serverless before, I hope now this is a bit clearer. Now let's get into the patterns. Let's get into some of the different ways you can build modern application by using serverless in different contexts too. So this is the typical web application where you have a browser. You usually want to split backend and front end. So your front end might just be a set of static objects, HTML, JavaScript, styles, images, whatnot. And you can serve all those assets through a CDN, and that's called Amazon CloudFront in the AWS world. And then what about your backend? Where is all the data and the dynamic information coming from? Well, you want to have some sort of RESTful HTTPS interface in front of your Lambda function. And that's a Amazon API gateway. And then you can finally have your business logic, your code, your Python, .NET, Go, Java, Node.js code, whatever it is. And here you receive an HTTP event from API gateway. And with that event, you can do whatever you want. You can go and fetch data from a database, for example. Here I have used DynamoDB. It's a NoSQL database, but it could be a PostgreSQL database or an Oracle database or a MySQL database, whatever you like. So your business logic here is not that different from what you would have with a regular, full stack framework, like Ruby or Rails or Django or Flask or Java Spring or those kind of frameworks. There are even ways to migrate those applications to Lambda. Although what usually happens is that you want to refactor that code a little bit to make it more performant, to make sure that your deployment package, the package that you deploy for each Lambda function is as small and as light as possible. Now, when it comes to API, we're talking about web applications, so the API gateway component here is pretty important. There are different ways of using APIs. One is by using edge-optimized endpoints, meaning that you have customers all over the world. You just want the API call to be as quick as possible, and you want to reduce latency on a global audience. There is a second endpoint type, the regional endpoint. In this case, there is no content delivery network involved, so there is no global optimization. It's meant for regional services that are already in that region. And in AWS, there are more than 22 or now 23 AWS regions, in a lot of different countries around the world. And when you deploy something, you deploy it to a region for most services. There are other services like S.T.A.Y and CloudFront that are global. They do not have regional deployments. Anyway, a third option is to have a private API. This is an API that is not accessible from the outside world, from the internet. It's only exposed inside a virtual private cloud. It's basically a private network inside your AWS account. Eventually, you can make sure some services or some people or some users can access that VPC, but by default, it's a private API. A lot of different details here. I think I'm a bit late on time. Okay, maybe I'll talk briefly about regional endpoints. So why do you want to have regional endpoints? I mentioned the use case where you have only regional service, but there is another very cool use case here. Let's imagine that you want to increase the reliability of your service. Okay, I'll make the usual example. Let's imagine you are Netflix and you have users all over the world. And if Netflix goes down for a minute, they lose, I don't know how many millions of dollars because they have a lot of customers concurrently using the service. So what they want to do is they want to increase their resiliency of their APIs, of their services, so that if something breaks, and remember, something will break. There is no way to avoid it. all you can do is build something that is resilient to failure. You can't really avoid failures at large scale. So what they do is that they deploy 2 different versions of their APIs, of their services. And then let's imagine these are in 2 different AWS regions. Maybe this one, let's talk about Europe. Maybe this one is in Milan and this one is in Frankfurt, or it could be Dublin and London, or it could be Paris and Oslo, 2 random regions. And then what they do is that via DNS, so using domain names, they make sure that if something goes wrong in any of the 2, they can forward the user, they can redirect the users to the application that is still working. Or they can do something even smarter. They can do latency-based DNS routing. Latency-based DNS routing. So you can say, hey, Route 53, that's a service that manages DNS, please send users to the closest region to them so that the latency is always optimal. So a lot of different reasons why you may want to have a regional endpoint. Let me skip over the private. This is a bit more into the on-premises scenario. Maybe you want your on-premises data center connect to AWS Direct Connect through your VPC and then talk to a service exposed via API gateway. There are a lot of scenarios like that, mostly for legacy systems or on-premises, hybrid kind of scenarios. Let's talk about security for a second too. Of course, you want everything to be served with HTTPS, and CloudFront does that for you. There isn't even an integration with a service named Amazon Certificate Manager. So that will even automatically renew the certificate for you. So you will never forget anymore about renewing your certificates. I just did it 2 weeks ago with an older domain I had, and I lost it, whatever. I should migrate it to AWS too. So with CloudFront, you also have additional features related to security. If you might have DDoS kind of attacks, denial of service, if you need some specific content to be available only to some customers of yours, you might use signed cookies or signed URLs so that you can sign the URL to a resource on S3, and only that person or only that IP will be able to access that object, maybe even with a time limitation. S3, of course, give you all the access policies possible in the world. They would take an hour. API Gateway does a lot of interesting, let's say, enterprise features, meaning if you need cross-account management, if you need throttling mechanism so that you can say, okay, this set of users can invoke my API only 10 times per minute. Okay, you want to throttle those API calls, and you can configure all these settings on the API Gateway level. Lambda has a lot of security integrations. You can manage environment variables. You can manage parameters and secrets by integrating with other services like the parameter store or the AWS Secrets Manager. Sorry about the number of services, but it's Amazon Web Services. We kind of build a lot of services. There are today more than 170 different services. And the most important things to remember for you tonight is you don't have to use them all. Maybe you will need 10 of them. Maybe you will need 30 of them, okay? Myself, I haven't used all of them, and it's totally fine. Don't worry. There is even a lot of complex way to manage custom authorization. You can plug in a custom Lambda authorizer even before your HTTP request is executed. So API Gateway will get the headers, pass it to a Lambda function that might integrate with SAML providers, Google, Facebook, other identity providers, and only then the API will be passed to your backend. So your backend Lambda function is not even invoked. And if it's not invoked, it's more secure, it's cheaper. You want to make sure only authorized clients are invoking your backend services. Let's talk for a little bit about data processing as well. In particular, I want to talk about streaming. And when it comes to streaming data, flows and logs and a lot of data coming from your existing systems, it could still be a web application like the front end, or a mobile application, or an IoT system, whatever. There are a lot of systems nowadays that just publish data periodically, or when something happens, like a click on a mobile application. So sometimes you want to handle that data, and there are a lot of different ways. Let's not talk about videos tonight, but there is a lot of services in the Amazon Kinesis family of services to handle data, to handle storage. You want to store those data directly into some other service, or to handle real-time analytics. Let me very briefly talk about that. My favorite service here is Amazon Kinesis Firehose. So you basically have some producer that push some data into Firehose. Then you configure Firehose to send that data to a downstream service like Amazon S.T.A.Y. or Amazon Redshift, like a data warehouse, or Elasticsearch if you need to do some other search queries. And Firehose will do that for you. There is no code that you need to write so far. Optionally, you can even plug in a Lambda function that will receive the incoming events, and that will be able to transform it, enrich it, filter it, do something with it, and then return it back to Firehose that will then push it to the downstream service. And the best thing is that Firehose does not force you to do any capacity planning. If there is zero data coming, you pay zero. It's exactly like Lambda. There is no sharding, there is no capacity planning to do at all. You only pay based on how much data is passing. Plus, you just click a few buttons and you can enable compression, you can enable Parquet transformation for analytical purposes to optimize your query. You can enable even a backup archive for your data, just to keep it there just in case, or even to reuse it in other environments, like in a staging or testing environment. With Kinesis data streams, that's slightly different, because what you want to do here is you receive a lot of events and you want to process those right there. You don't want to store it somewhere, you want to process it in real time. So here it's slightly less serverless, because you have to configure the number of shards. And if you think about it, number of shards, it's kind of like configuring the number of servers under the hood. So it kind of pushes you to do some capacity planning, because each shard or each server allows you a given throughput, incoming and outcoming. There are multiple ways to optimize it. Let's move forward for now. When it comes to real time, okay, let's imagine that you have some IoT devices here that produce some records, and you want to optimize, you want to analyze all this incoming data in real time. Let's imagine that you have devices across different rooms in a building, or even across multiple buildings, and they are sending periodic information about temperature, pressure, whatever. You want to trigger an alarm or send a notification to an operator, let's say if the average temperature in a specific building or in a specific room goes above or below a given value. So how can you do that? You might have thousands of devices across hundreds of buildings, and they are all sending a lot of data. So you can always do some post-processing. But if you want to do is real-time analytics, let's say every 10 seconds or every 30 seconds. So what you can do is you put in there Kinesis data analytics. You provide an SQL query that will run on this incoming data, and the output of this query will be streamed to a Lambda function. So let's imagine here you put your business logic, like if average temperature is above 20 in this building, trigger an SNS notification that will notify an operator, for example. All great, but how do you actually build the query, the SQL query here? Let me show it to you. So you can just select the stream, you can select the device ID. Here I am, it's not really real time here. I am creating a window of 10 minutes, but the window could be 10 seconds or 60 seconds, as long as you want. And then I can do all sort of aggregations. I could compute sums or averages or counts, typical SQL kind of queries. And then you can group by and filter and do whatever you want. So the output of this query will go to a Lambda function, and maybe the Lambda function will only receive the average temperature categorized by building. And you can very, very easily build that business logic in a event-driven fashion every 10 seconds. Okay, that will be very, very hard to build otherwise. Let's talk about data analytics in general, not just real time, but historical data, building reports, building analytics at large scale. And then you have a lot of different services around it for cataloging, for accessing, for processing, for auditing or securing or encrypting or ingesting. So we have already seen how we can do data ingestion with Kinesis Fyros all the way to S3. So you just put records, 0 lines of code written, and all your data will be already on S3 in a lot of different objects, maybe in JSON format or CSV format. That's up to you. Let me show you how you can go and query that data that is already stored on Amazon S3. So the super easy way is to use a service called Amazon Athena. You can even automatically discover the schema of that data. So you can throw a lot of data in there, and then you send out some crawlers. The crawlers will find the schema, create a virtual table for you. And once you have a virtual table, you can use Athena to query that virtual table without moving data around. The data is still on S3, so Athena is not a database. And then eventually you can go and use Amazon QuickSight, for example, for data visualization and data exploration purposes. But what does Athena look like? Well, pretty intuitive interface. You have your tables in here, you have your query, and the blue button to run the query. Super simple. Of course, as every other AWS service, you can do exactly the same stuff via API. Everything is automatable. Everything can work via API as well. Let me just show you a query with Athena. In this case, I'm using a public data set called the Google Ngrams. There is a lot of data in there. I think it's more than a few terabytes. I have the exact number in a second. So let's imagine that I'm selecting a few fields. I'm doing some aggregation. I am filtering a specific gram, meaning that I am scanning only a very specific part of the database, of the data set. And then I'm doing some grouping and some ordering. Now, this query runs in about 45 seconds on Athena. But I can assure you, you try to run this on your laptop with a full Ngrams data set, it will probably run for a few hours. On my laptop, probably a few days. Let me know. Why? Because the data that was scanned was about 170 gigabytes. And that's only a small segment, a small section of the data just corresponding to this gram. There is a lot more. I believe that the full data set is about 2 or 3 terabytes, but maybe more. And the price of this query is about 85 cents of a dollar. So that's like 75 cents in euros. And why is that? Because like almost everything in the serverless world, there is no server, there's no cluster, there is no capacity planning, there is nothing running 24/7 if nothing is happening. You pay for Athena based on how much data was scanned during your query. So the official pricing is about $5 per terabyte. So here we are scanning about 170 gigabytes, so we pay about, nothing. But in the typical data set, I've been working with data sets like 200, 500, 600 megabytes. One query will be something like less than a cent of a dollar. So super, super effective. You can run that query 10 times a day for a year, and you will still pay something like $1 or $2. And this is massively different. If you need a data warehouse or a larger database in general, we're talking about $50, $100, $200 a month minimum range if you want to have a server running 24/7 waiting for some query. So this is a very different model if you think about it. And there are even people that are bringing this idea to the next level. People are doing MapReduce kind of workloads using S3 and Lambda, because basically you can say every time there is a new object, or every time an object is modified or deleted or updated, you can trigger a Lambda function. So everything is event driven. With that idea, you can easily scale out and scale in to do kind of mapping and reducing kind of tasks. There is even a framework from the University of California in Berkeley that built PyRen, reaching up to 40 teraflops of compute capacity, of compute power, going over 700 gigabyte per second of throughput, read and write performance. I mean, these are numbers that 10 or 20 years ago would be in the top 100 most powerful computers in the world. And now you can have it with an open source framework in the cloud for 5 minutes, spending less than $1. I mean, this is, if you still think the cloud is just somebody else's computer, I'm sorry. Come back to me. Maybe we should meet in person and talk in front of a coffee. There is even more research being done. If you know NumPy, these guys have been built a NumPy-Ren version of it, just using serverless architecture to implement linear algebra kind of algorithms, like matrix multiplication kind of workloads. Let's get into the last category of patterns. Let's get into artificial intelligence and machine learning. There is a lot of services in this space, and we don't have time to go through it in 5 minutes. But what I want to focus on is the high layer up there. There is a lot here, like a lot of machine learning services like SageMaker, a lot of framework compatibility, a lot of framework support, GPU drivers. There is a lot in this medium and lower layers for data scientists. But if you're a web developer, if you have an IoT developer, if you're a developer without a mathematical background or engineering background, there is still a lot up here that you can use just to integrate some smart functionalities into your applications. Things like finding objects in an image, or converting audio into text or text into audio, or building a chatbot or creating a recommendation engine. You don't need to be a machine learning specialist. All you need to do is to be able to call an API call, a RESTful HTTP call to one of these services by using one of the SDKs. If you're using Python, Go, Node.js, Java, there is an SDK for basically every language. So if you can install the SDK, create a client for one of these services and do one method invocation, you can integrate these services into your own product or your own project. Let me give you a few examples. Let's imagine that you have a system where users, maybe through a mobile application, can upload an image. So you can store this image directly into S3. There is no need to have a server to receive that image, to parse it, to secure it. You just push it directly to S3 from the client. And then, using an event, you trigger a Lambda function that will run a few different things in parallel. It doesn't matter about step functions a lot. Let's say we are running a few different things in parallel, and we want to use Amazon recognition that can operate on that image and do different things. You can find faces, you can find objects and labels, you can detect moderation and nudity on that image, you can find text on that image, like optical character recognition, and you can do all these things with one API call. And then you get the results back, and maybe you store it in a database, or you store it on Elasticsearch, and then maybe you want to have these users being able to search for the metadata about the images that they have uploaded. So do you really want to rebuild a machine learning model that is able to detect labels, objects, faces, or text from an image. No, that problem has been solved. You can just integrate it with a couple of API calls. A very simple example where we want to do multiple things, because in this case we have videos. So maybe we want to transcode that video. We want to take the audio channel of that video and transcribe it into text with Amazon Transcribe. Then we can use Amazon Comprehend to analyze the language content of that text. And maybe we can store all this information again into Elasticsearch to provide another API to those same users to search. This could be a media catalog kind of solution. Let's talk about call centers. There is Amazon Connect. It's a call center as a service, completely serverless. There is nothing to install, and there is no cluster or server to manage. So let's imagine that it's 2 a.m. and Anna, our customer, wants to reschedule an appointment. And maybe you have a healthcare, private healthcare company, whatever. And Anna wants to call, and instead of talking to a person, an agent, because it's 2 a.m., nobody wants to work at 2 a.m. So she talks to Connect. She can text, talk, or do whatever she wants with Connect. Connect understand everything. And behind the scenes, you will have Amazon Lex. Amazon Lex is very similar to, if you're familiar with Amazon Alexa skills, Lex is kind of a similar engine. So Lex will be able to analyze the conversation, extrapolate, extract the useful information, like, okay, what appointment do you want to reschedule? What's the next date, the new date that you want to reschedule this appointment? And then Lex will be able to pass that information to a Lambda function that maybe will check on the database first, is it correct? Do we have availability in the new date? And once everything is done and updated, you can send a push notification back to the customer. So you can do all of this. Basically, you build a smart and intelligent call center. But let's imagine that it's not 2 a.m. So it's 2 p.m. In the afternoon, and you have your agents connecting to Amazon Connect and talking to your customers. So they can have conversations, and Amazon Connect will automatically send to Kinesis data firehose all the contact trace records, basically everything related to the call, how long did it last, who was speaking, blah, blah, blah. And so you have all this data on Amazon S3. But at the same time, it will send the raw recording, the audio recording to S3. And you can use a similar solution, trigger a Lambda function, use transcribe to convert the audio to text, and save the transcript to another S3 bucket. And then in a similar fashion, you can take that text and transform it and analyze it and comprehend it and extract sentiment, extract key phrases, and all sort of things. If you notice, we now have a lot of data on S3, and we could just analyze it, because this is basically a data lake. So we have all the historical data about our contact center available on S3, all the contact trace records, all the transcript, and all the metadata about sentiment and key phrases. We can use services like Athena to query this kind of information, and we can use QuickSight to visualize this kind of information. And we are using 0 servers. We have done 0 capacity planning. If nothing happens for a month, you pay 0, because there is no server running and idling if nothing happens. So this is a different way of thinking about architectures, in my opinion. Let's imagine that you want to use something like Amazon Personalize to build a recommendation engine. You just provide your data about what can be recommended. If you're Netflix, it will be movies. If you are an e-commerce, it will be your items in the e-commerce. You provide that data, and Personalize will take a few minutes or even hours. It will do some training and come back with a custom API that you can easily integrate with your web service. So you have your browser. Your browser will send live event directly to Amazon Personalize, like, I have clicked here, I have visited this item, I have bought this item, just to keep the recommendation engine up to date. And then at some point, the user interface can request a list of recommendations. Hey, give me some recommendation for this user. And your web server is just going to ask it to Amazon personalize. They will come back with some recommendations. Maybe here you can augment it, customize it even more, fetch some additional data from the database, and then return it back to the browser. So it's super, super easy to integrate with your own existing servers or not.
Okay,
And
Alex.
with this, I'm done, guys.
Okay, cool.
This is the last slide. So a few reminders, some takeaways for you. The cloud is not just someone else's computer. It allows you to build faster and cheaper. Serverless is the same idea, but at the higher abstraction layer. So it takes you to the next level. And remember, it's not just AWS Lambda. It's not just computing power. It's the rest of the ecosystem. It's the rest of the serverless platform for authentication and analytics and machine learning and everything else that you need in your architecture. That's all. I hope you go and build something awesome on AWS. Let me know what you build.
All right.
Thanks, Alex, for your presentation.
Thank you very much.
As you can imagine, we already got a couple of questions.
Yep.
I will start with the first one. So, well, it's just a joke. So, should we stream the next Speck&Tech via AWS? Is it compatible with OBS?
Well, maybe. I do have OBS. We can give it a try. I'm not in good relationship with OBS, to
Me
be honest.
neither. That's why I'm asking the question. Actually, I'm having trouble all the time. Sorry, people, for my Discord for an instant.
Okay.
It doesn't actually run on my MacBook very, very well.
I'm using a PC.
On a computer.
Yeah, I have a dedicated PC. I mean, it's not just his job to run OBS, but it definitely goes better on a PC than on a Mac.
Believe it or not, the last time I ran OBS, I ran it on an Amazon Workspaces instance because my MacBook couldn't do it. So I'm using the cloud even for OBS.
That's actually a good idea.
Okay, moving on to most serious questions. First one, one of the users asks, my biggest fear with function as a service is vendor lock-in. Is there any standard to ensure portability?
So there are some efforts in standardizing the event payload, for example. So there have been some efforts. I haven't seen something concretely accepted by all the vendors or by all the frameworks and infrastructure as code services and so on. I have my own opinions on lock-in even before I joined AWS. And my answer for you as a developer is that, hey, every choice you take in IT, in development, will kind of push you into some lock-in, but I don't like to call it lock-in. Let's say that every choice you take will have a cost for coming back or for changing that decision. So let's say that you have chosen Node.js for your development. Did it ever occur to you that if you wanted to switch to Python at some day, you have locked into Node.js, you have taken that decision because Node.js is more comfortable to you, or because it's easier to hire people on the market who are familiar with it, or because there is a competitive advantage, so you can go faster, so you can build whatever you need to build in a better way. And I think that mindset applies to the cloud. If you choose the cloud, it's because you'll be faster, you will have a competitive advantage. And, of course, coming back, changing everything will have a related cost, like changing from Python to Node.js. But as long as it gives you competitive advantage, that's your decision. And I like to think of it in terms of the cost of changing or rolling back a decision instead of locking in. But I totally understand.
So it's the old answer, it depends.
It depends. In a few words, it depends.
Yeah.
Okay, I'll go with the next one, which is, okay, you told us about a lot of interesting things that you can do with AWS services, but what are the genuine drawbacks of a serverless architecture if you have to be kind of transparent?
Good point. Absolutely. I think right now, it's been 5-6 years since, this serverless thing was started in the development community. And I think as every new methodology, as every new community, the biggest challenge is adoption and the friction to change, and the idea that you have to learn something new and a new framework and a new way of thinking about architecture. So I think from a developer and also from a business point of view, if you take that road, you probably have to change something in the way you are developing code or in the framework you're using. If you're used to Django or Express.js or Flask or Spring for Java, those frameworks are not 100% the best choice when you go and develop serverless, Lambda functions, for example. So that might be a drawback. But again, my argument is with any new technology, there is a friction to change, and the early adopters are the pioneers, and they will probably get some competitive advantage over the others that do not. So if you are a learner, someone who enjoys learning new stuff and doesn't see that as a obstacle, but as an opportunity like me, I would say still go for it. But there is some new stuff that you need to learn. It's not the same world.
Okay.
All right.
Thanks, Alex.
So thanks a lot, Alex. Thank you very much.
And yeah, unfortunately, you won't get the room.
We don't have a actual crowd, so you can write a lot of emoji of clapping on the chat right now if you want to express your emotions, which is super sad.
Please don't do it. Please don't do it.
We really miss you, people.
Yeah. Okay, thanks again, Alex. Of course, the video will be available on our YouTube channel, so if anyone missed any of the parts, can go back and rewatch it whenever you like it. If you've got questions, I guess you can shoot them directly to Alex as well. I know that he's quite active on Twitter, so just head on to him directly. Just to wrap up the night, I know that many of you are very, very curious about the results of our survey.
Yeah, me too.
And what?
Me too.
You too.
I don't have access to Slido as an admin, so I don't know what the result is.
It's quite surprising at the moment, but the skin pink tea with the dark brown design is winning. It's around 60-something%. I'm not gonna say again that it was my favorite, that I didn't touch the votes, I promise, I swear. But the dark military green tea is around 40%. Still, the battle is on. We will decide what we were gonna do with these votes, if we're gonna open to the whole community in the coming days, or we're gonna stick to these results. But at the moment, it seems that we're gonna have a new T-shirt in the coming months, and we'll keep you posted on our channels. That is mostly it from all of us. I guess we can say goodbye to the people on YouTube, as this video will stay.
Yeah, and if you have any question about which service you should use next time, just write Alex on Twitter. It's easier than the Amazon guide on their website. This kind of a meme.
Help, guys. No problem.
So he's happy to reply your questions.
See you everyone on YouTube, and we turn off the light for tonight.
Yeah, we are closing the streaming now. Bye. And it's closed.
Okay.